Hi friends, in this session we will study about the direction cosines and direction ratio of a point in 3 dimensions. So let us see, first I explain you about this figure. This is our blue line represent the x-axis, in the space red is y-axis and green one is z-axis, and this is our origin of space we have taken here. So let us take a point P in a space. This is our P point in a space. We join this P point to origin. So let us see, this is a P point to origin. Join this, and this OP makes the angle with positive direction of x, y and z axis. It is we give them name like this. If this angle is OP makes alpha angle with positive direction of x, so this one is called alpha, and with that y axis it makes angle beta, this one is beta, and with z axis it makes gamma, positive direction. So alpha, beta and gamma we have here. If we take the cosines of all three, we get cos alpha, cos beta and cos gamma. So in this way we get all the cosines. These are called the direction cosines. Now we assume that the coordinates of point P are x, y, z. Coordinates of this point are x, y, z. Or I draw a line perpendicular on x axis, on y axis, on z axis directly. So I see what happens. Let us see what happens here if we draw this line perpendicular on x axis. So this is the perpendicular I draw on x axis, one perpendicular I draw on y axis now, one on z axis. This perpendicular we have drawn on all the axes from point P directly. So you see here, this angle is 90 degree here, this angle is 90 degree here, this angle is 90 degree, and OP, we assume that the distance of OP is R. OP is R. So in this triangle, this is our point A, this is our point B, and this is our point C. From OA it is X, because the X, Y, Z is the coordinates of P. So because we are making the perpendicular from P on X axis, which is PA, so OA would be X, this would be X, and OB Y, and OC Z. Okay, so in this triangle PAO, in triangle PAO, angle A is 90 degree. We have drawn perpendicular from P on x axis, and angle O, which we have taken alpha with x-axis positive direction of x-axis the angle. So in this triangle PAO, so because OA is the base of this triangle OPA, OA is the base, so OA over OP, which is the hypotenuse of this triangle. OP is the hypotenuse because it is opposite to the right angle, and there is the 90 degrees we have drawn here, the perpendicular, so it is opposite to this right angle, so it is the hypotenuse. So OP is base and OP is hypotenuse, so base over hypotenuse is cos alpha. Now OA, we know that OA is x and OP is r, is equal to cos alpha. So x is equal to r cos alpha. Similarly, we could find out OB over OP is equal to cos beta. So y over r is equal to cos beta, then y is equal to r cos beta. The same way we could find out OC over OP is equal to cos gamma. OC over r, OC, we know the value of OC. OC is y, OC is z, z over r is equal to cos gamma. So z is equal to r cos gamma. So we have got all the direction cosines we could easily find out if we know these things. Now we see some more thing here. We have got the direction cosines, the cos alpha is equal to r, cos alpha is equal to x over r, cos beta is equal to y over r, and cos gamma is equal to z over r. Now this is our equation 1. I give some name to these equations. This one is first equation, this one is second equation, and this one is third equation. So what we do here, first we square and add all the equation. Square and add all equations. Okay, so we see here, we get here x square plus y square plus z square, r square common in all three, r square cos square alpha, r square cos square beta, r square cos square gamma. So we are taking r square outside common, cos square alpha, cos square beta, cos square gamma. So we have got this thing. Now we know that OP, I explain you one thing more here. Here you see OP, the distance of OP, the point or the origin point where the coordinates of O is 0 0 0 and these are x y z. So OP is equal to, first I explain you OP. OP square is equal to x square plus y square plus z square by the distance formula, x minus 0 whole square, y minus 0 whole square, z minus 0 whole square. So it would be, and the OP is r, so it is equal to r square. So instead of this x square plus y square plus z square, we could put r square. So r square is equal to r square cos square alpha, cos square beta, cos square gamma. So here we see these both r square will eliminate to each other. We will get here one only. So 1 is equal to cos square alpha plus cos square beta plus cos square gamma. So if we assume that L is equal to cos alpha, the value of cos alpha is equal to m is equal to cos beta, and n is equal to cos gamma. So we can also write this formula in this way: L square plus m square plus n square is equal to 1. So this is also one way by which we could easily find it out, the direction cosine. Just a moment. So L square plus m square plus n square is equal to 1. It means that the square of all direction cosine, the sum of the square of all direction cosine is always equal to 1. So this is the relations between the direction cosines of a point. Now let us see what is direction ratio. Direction ratio, I explain first. We have a number 2, 3 and 6. This number we have, if I divide 2 by 6 and 3 by 9 and 6 by 18, so I get all the ratios are now same. You see here, we get here through all would be 1 by 3. Here 2 over 6 is 1 by 3, 3 over 9 is 1 by 3, and 6 over 18 is 1 by 3. So these numbers which make it in same proportion are called direction ratio, 6, 9 and 18. Similarly, if we have L, M and N are the direction cosines, we divide some other numbers. These are, so x over A, m over b and n over c, it makes it in same proportion. So a, b, c are called direction ratio. So a, b, c are direction ratio. A, b and c are direction ratios. Now by the law of ratio and proportion, we get one more thing out of this. L over A is equal to m over b is equal to n over c is equal to plus minus square root of L square plus m square plus n square over square root of a square plus b square plus c square. So you see here, if we have to find out this, the law of ratio and proportion, we could do in this way. So L over A is equal to plus minus, because the L square plus m square plus n square we already know it is equal to 1. You see here, it is equal to 1. So you will put here 1 over root a square plus b square plus c square. A we transfer to other side, we will get here L is equal to plus minus a over root a square plus b square plus c square. Similarly, for m, plus minus b over root of a square plus b square plus c square. Similarly, n is equal to plus minus c over root a square plus b square plus c square. So in this way we could easily find out, if they have given us the direction ratios, we have to find out the direction cosines. So putting these values here instead of a, b, c and c, we could easily find out the direction cosines. Or this property is very useful to differentiate direction ratio, direction cosine. If they have given direction only. They put that it is the direction, they have not mentioned it either it is cosine or ratio. So you could put the values here, L square plus M square plus N square, and this form we get 1. So it is the direction, and these are direction cosines, otherwise these are direction ratio. So I think it is sufficient in this session. I will explain you something more about the 3D. It is very interesting uh, uh, subject of geometry, 3D. There are so many things. There are projections, there are direction cosines of a line segment, how we would get if we know the coordinates of a point of a line segment, we have to find the direction cosines, and so many things are there. The angle between two lines through 3D, we have to find out. So many things are there, so many interesting things are there in 3D. We will see in our for coming episodes or the seasons.